In this section, we're going to work on adding and subtracting mixed numbers. Suppose you have 2 3/4 and you have 4 2/4. You can think of this as $2.75. You can think of this as $4 2/4 is 50 cents. You can add them up and you're going to get 7 1/4. The only thing you should do now is, well, first, let me say we're adding $4 2/4. Now, you could ignore the units. 7 1/4. Okay. That's just to show you that you know how to do this problem. Well, you have 3/4 and you add 2/4. So you have 5/4. 2 plus 4 is 6. Now, this is improper. So we need to convert it. First of all, this is 6 plus 5/4. This is also 2 plus 3/4. And 4 2/4 is 4 plus 2/4. Well, 6 is 6. And 5 divided by 4, well, 4 goes into 5 one time with 1 left over. It's 1 1/4. You want to work it out? Go for it. 4 into 5 goes one time. 1 times 4 is 4. Subtract. You get a remainder of 1, which gets divided by 4. And remember, this is 6 plus 1 1/4, which is 1 plus 1/4. You can skip some of these steps if you like. That's 7 plus 1/4. 7 1/4. If you can go from 6 plus 1 1/4 to 7 1/4, fine. My job is to show you why, not to show you the most elegant way or the quickest way of doing the problem. Suppose you have 7 2/11 and you want to add 8 3/4. Well, before you can add the fractional part, so let's put that on the side, you have to have common denominators. Now, the 11 table is pretty easy. It's 11, 22, 33, 44. 4 doesn't go in here. It doesn't go in here. Why? Because 4 times 3 is just above. 4 times 2 is too little. 4 times 5 is 20. 4 times 6 is too much. 4 times 8 is 32, but 4 times 9 is too much. But here it is. This is 4 times 11. So this number is on the 4 table. You don't believe it? You can write it out. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. 44 is the first number on both lists. So I want to write 2 over 11 as something over 44. So I can take 2 over 11 and multiply it by 1. If I multiply it by 1, this times this may not look like that anymore, but this times 1, 100% equals 2 over 11. And I'm going to write the 1 as 4 over 4 for one reason and one reason only. 11 times 4 is 44. And there's a second reason, because it equals 1. And 2 times 4 is 8. So these two numbers, they don't look the same, but they're equal. Now, Same game with 3/4. I want to write it with a 44 on the bottom. Now, a number is equals to itself times 1. 4 times 11 gives me 44. If this fraction has any hopes of being 11, and the bottom has to be 11, if this fraction has any hope of equaling 1, and the bottom has to be 11, then so does the top. 3 times 11 is 33. So what I just discovered was adding these two numbers is the same as adding those two numbers. Since they have common denominators and we're adding, we keep the denominator and we add the numerators, which is 41. So when I add those fractions, I get 41 over 44, and the whole numbers I get 15. And before you say that you're done with the fractional part, ask yourself if you could reduce it. And now the only numbers that go into 44 evenly, where the prime factors are, you can see it. It's 11 times 4, which is 2 squared. And 41, if I'm not mistaken, is prime. Okay, they have no common factors. This has factors. That's the prime factorization. They don't share any common factors. So you're gonna have a hard time reducing it. This is the answer. Let us consider 8 5/7 plus 9 4/7. The denominators are the same. That's real helpful. To keep them the same, add the numerators. 8 plus 9 is 17. So this is 17 plus 9 over 7. The reason I'm not stopping right here is that's improper. It's 1 or more. And this becomes 1 2/9. After all, 7 goes into 9 one time with 2 left over. 1 2/7, excuse me. 1 2/7. Okay, that's where you check. 1 2/7. And 17 plus 1 is 18, plus 2/7. 18 2/7. So it equals 18 2/7. Let us try another one. Let's do a subtraction problem. Suppose you have 7 3/5 and you want to take away 2 1/5. The denominators are the same, that's good. And 3 minus 1 is 2. And 7 minus 2 is 5. And this is not improper. So you're done. The answer is 5 2/5. However, what if you had 7 3/5 and you want to take away 2 4/5? Problem here is, just like in regular subtraction, if you have 24 and you want to take away 15, since this number is larger than that number, you can't do 4 minus 5. You have to borrow to make this number more than 5. So we need to do the same thing here. But you just have to think and not just do things blindly. Let's work it out over here. Many students may say, well, this is simple. I'll borrow here and I'll make that 13. Well, let's look at that. So you have 3 over 5. Now, what did you add to get 13 over 5? And I'll give you a hint. The answer is something over 5. Well, 3 plus 10 is 13. So now I borrowed 1, but I added 10 over 5, which happens to be 2. That doesn't work. If you have, I don't know, 7 or 8 and 2/3, and you want to borrow, so you make this a 7 and you make that a 12. This is 7 and 12/13. Well, if you have 2/3, what did you add to get 12 over 3? The answer is 2 plus 10. You added 10/3, but this is not 1. You borrowed 1, but then you added 10/3. That doesn't make it. That just doesn't work. So you have to think about how it will work. If you have 7 3/5 and you borrow 1. So basically you want to add 1 here. How about as 5 over 5? So then you get 6 8/5. What you want to do is add this number to top and bottom. And you're going to get 6 8/5. I borrow 1 here, and I have to add 1. Not that type of 1. That's adding 10 over 5. I'm supposed to only add 5 over 5, which gives me 8/5. Again, when you have 7 3/5 and you borrow 1, you have every right just to add the bottom number to the top. If you have 6 7/9 and you borrow, you really want to add 9 over 9. That is, you want to add 9 to that top. You always want to add the bottom number to the top. Okay, so now we have 8/5, and we're taking away 4/5. 8 minus 4 is 4, and then we have 6 minus 2, which is 4. 4/5 is not improper, so we're done. Let's try another subtraction problem. Oh, okay. How about you have 34 7/15, and you want to take away 10 and 11/15. Well, you only have 7/15, and here you're trying to take away more, trying to take away 11/15. So you need to borrow. So you borrow from the 1s, and now you have to add 1 to the 7/15. That means just add 15 to the top. Get 22. And let's see if we're right. If you have 7 over 15, what did you add to get 22 over 15? Well, the answer is going to be over 15. So when I add fractions with the same denominator, I get the same denominator. And it turns out that 7 plus 15 gives me 22. And then I smile because I realize, oh, I added 1. I borrowed 1, and then I added 1. 22 over 15 minus 11 over 15. Well, it's over 15. 22 minus 11 is 11. 3 minus 0. 3 minus 1. 23 and 11/15. And we are done because this fraction is proper. The numerator is less than the denominator. Suppose you had 5/11 and you just want to add 1. Now, there's 2 ways to tackle this. you can say is 5 over 11 plus, for the 1, say 11 over 11. That way they both have the same denominator, and in addition, if they're the same denominator, keep it. 5 plus 11, 16, be on your way. Or you can say, you don't have to write this if you don't want. This is 1 plus 11 fifths. 1 plus 5 elevenths, which is 1 and 5 elevenths. And we learned earlier that 11 times 1, which is 11, plus 5 more is 16. That's the numerator, and you keep the denominator. Now, in both cases, if you want to write it as a mixed number, it's really easy. 5 over 11 plus 1 is just 1 and 5 elevenths, and you're done. 11 goes into 16 one time with 5 left over. So if you just want to write it, if you want to write it as a fraction, you can do it one of those two ways, either way. If you want to write it as a number, as a mixed fraction or mixed number, excuse me, it's easy. It's just 1 and 5 elevenths. If you have 7 over 15 plus 1, and you want to write it as a mixed number, it couldn't be any easier. If you wanted to write this as a mixed number, there it is. Even if you want to write it as a fraction, it's not so bad to go this way, because then you can go 15 times 1 is 15, plus 7 is 22. Over here, you can go 15 times 3 is 45, plus 7 is 52. And then you get it as a fraction, which you should attempt to reduce if possible. Okay. How about we go back to subtraction? Yeah, 78 and 3/7, but you want to take away 6 and 5/7. Well, you can't do the fraction part without borrowing. So you borrow 1 from the 8, and then whatever this denominator is, you add it to the top. Why? Because when you add the 1 you just borrowed, well, what's happening to the numerator? You're adding 7 to what it used to be. And the denominator doesn't change. You're just adding the numerator, you're just adding the denominator to the numerator. There it is. For example, if you have, 8 over 11, you want to add 1, which is like 11 over 11. Well, you keep the common denominator and you add 8 and 11. But you could have just said, then when I add 1, I'm just going to get 11 plus 8, which is 19, and I keep the common denominator. Now that I have 10 over 7, I can take away just 5 of them. The 7 stays. 10 minus 5 is 5. 7 minus 6 is 1. 7 minus 1 is 6. And there is your answer. This is proper, so we are done. Let's consider this problem. Suppose you have 98 and 4/8, and you want to take away 16 and 7 over 8. Now, you can definitely reduce the 4 over 8 to a half, but then they won't have common denominators. So definitely don't reduce it. I would say reduce it if this was 4 over 8 and this was 3 over 8. This would reduce to 2/4, and this would reduce to 3/4. I would not reduce that to a half, because then the denominators are not the same. So be careful with reducing. Okay, so we have the same old problem. You only have 4/8, and you're trying to take away more than 4/8. Trying to take away 7/8. So you have to borrow 1 and add 1 to the fractional part, which just means don't add 10, which would be just putting a little 1 up there. You have to add 1, which is 8/8. So now you have 12/8 minus 7/8. That's 5/8. 7 minus 6 is straightforward. 9 minus 1 is straightforward. This cannot be reduced, and it's not improper. How about you have this one? What if you have 405/7 and you want to take away 16 6/7? So you want to borrow 1 for the fraction. You want to borrow 1 because you can't take away 5/7. Can't take away 6/7 from 5/7. So you borrow from the 400. You borrow 1. You get 399. And then you add the 7 to the top. 7 plus 5 is 12. You subtract. The denominators are the same, so it stays the same. 12 minus 6 is 6. 9 minus 6 is 3. 9 minus 1 is 8. Don't forget to bring down the 3. And there is your possible final answer. Make sure that this cannot be reduced, and also make sure it's not improper. Sometimes it could be. Let's do one where it'll be improper. Suppose you have 72 minus 16, and you have 6/8, and you want to take away 4/8. But I just want to change those numbers to 5 and 3. Now, you can't reduce 5/8. You can't reduce 3/8. So when you subtract, since they're both 8, 5 minus 3 is 2. Borrow 1. Make that a 12. 12 minus 6 is 6. 6 minus 1 is 5. But this can be reduced. I can divide top and bottom by 2. It's 56 1/4. Now, just want to talk about something. Why did we just add a 10 here? And the reason is that this is the tens place. I borrowed 1 10 and I add on 10 ones. That's legit. Okay, this here is the tens place. I have 7 10s and 2 1s. If you have 7 10s and 2 1s, and you go to the bank and you hand them one of your $10 bills, so now you have 6, and you ask the teller, please give me 10 1s. So now you're gonna have 12 1s. 6 10s, which is 60, and 12 1s, which is 12. That added up to what you started with. What if you have this, and you need to, so that's the hundredths place, and you needed to borrow because that's not enough. Because maybe you want to take away 271. So 4 minus 1 is 3, but you can't do 2 minus 7. So you borrow 100. So right now, think you have $300 bills you have 2 $10 bills, and you have 4 $1 bills. And you go to the bank and you say, here is one of my $100 bills. So now you only have 2 $100 bills. And you say, please give me $10 bills. Well, it turns out that 10 $10 bills is a $100 bill. So instead of having 2 $10 bills, you're going to have 10 more. You're going to have 12. That's because these numbers are always multiplied by 10. That is, the ones times 10 gives me the hundreds, times 10 gives the ones, times 10 gives me the tens, times 10 gives me the hundreds, times 10 gives me the thousands, times 10 gives me the 10,000s. So this number is always 10 times that number. So if you borrowed 1, if this was 3 and this was 4, if you borrowed 1, you only have 2 of those, whether they're 10,000s or millions, and when you put them at the place immediately to the right, you're going to have 10 more of those. If you have 3 10,000s and you have 4 thousands and you borrow, you go to the bank, make believe please that there's a $10,000 bill, and you have 3 of them, but you go to the bank and you surrender 1 of the $10,000 bills. So now you have 2, and you say, please give me $1,000 bills. Well, they're going to give you 10 more, not 10 more, they're going to give you $10,000 bills for your $10,000 bill. So now you'll have 4 plus 10, which is 14. Base 10 is neat. If you take 2 and you add 10, it's like taking the 2 and putting a 1 next to it. If you have 7 and you add 10, it's like taking the 7 and putting a little 1 next to it. That's the property of base 10. What goes wrong here is this is not in base 10. Okay, so let us do one that is in base 10. What if you have 37 and 3/10, and you want to take away 22 and 7/10? So here you borrow 1 1 and you're gonna add on 1 as 10/10. But 3 plus 10 is just like putting a 1 there. So in this case it works. 13 minus 7 is 6 over the common denominator. 6 minus 2, 3 minus 2. The final answer would be 14 3/5 because 2 goes into both of those numbers. So now remember, if you have 37, say 0.1, this is the tens, the ones, let's put a 4 here, and this is their 10th position. A tenth of a dollar is a dime. If you go to the bank and you hand them one of your dollars, so now you only have $36, and you say, please convert this dollar into tenths of a dollar, that is dimes. Well, they will hand you 10 dimes, so now you'll have 14. The thing is that this is the same as 34 and 4/10, because that's the 10th position. It's 10 times that. Sorry, this is 10 times that. So if you borrow something from the ones and you put them into their 10th position, it's like just putting a 1 there. You'll now have 14. So in this case, we can just put a 1 there. Why? And call it 14/10. The reason is if you have 14/10 and you add 1 as 10 over 10, this way we have common denominators, you'll get 14 over 10. Okay, think about this. Don't do things blindly. How about we do a different type of problem? Suppose you have 3 hours, 24 minutes, and 13 seconds. And you want to subtract 1 hour, 46 minutes, and 24 seconds. So the first thing you try to do is 3 minus 4, and you can't. Let's even make this as 3 and make this a little bit bigger. Okay, so first thing you can do is, now this is the 1 seconds position, and that's the 10 seconds position. This is 23 seconds. So I can borrow 10 seconds, 10 seconds, and add on 10 seconds. Now 13 minus 4 is doable. It's 9. The problem is now I can't do the 1 take away this 3. So I borrow a minute. So now I have 23 minutes. The thing is 1 minute is equal to 60 seconds. So I have, which is 10 seconds. So in the 10 seconds position, I'm going to add 6. So now I have 70 seconds, or 10 seconds. And I'm going to take away 3, and now I have 49 seconds. Now I attempt to do 3 minus 6, which I can't do. So I have to borrow here. But these are the same units. It's like 23 minus 46. I borrow 1. That's from the 10 minutes. And I convert the 1 10 minutes into 10 1 minutes. So instead of having 3 1 minutes, I now have 10 more. That is, I have 13 minutes, and I take away 6, so I have 7 minutes. Now I'm stuck. I have 1 10 minute, and I'm attempting to take away 4 10 minutes. So I have to borrow. Instead of having 3 hours, I now have 2 hours. Once again, 1 hour is not 10 minutes. It is 60 minutes. So I have to add 60. So I'll add 6 to the tens position. Instead of just having 1 10 minutes, I now have 7 10 minutes. And I can take away 4 of them. So I'm left with 3 10 minutes, or a total of 37 minutes, and also 29 seconds. And then 2 minus 1 is very doable. It's 1. So if something used to take you 3 hours, 24 minutes, and 23 seconds, and you reduce the time by 1 hour, 46 minutes, and 34 seconds, it now will take you 1 hour, 37 minutes, and 49 seconds. Okay. Knowing how to do this is really important. Just do it nice and carefully. Just remember that when you borrow a minute, you have to add on 60 seconds. When you borrow an hour, you have to add on 60 minutes. And if you had, I don't know, 22 hours or 13 minutes and 23 seconds and 2 days. Make it 3 days. You want to take away 1 day, 21 hours, 12 minutes, and 23 seconds. But look, okay, so when you subtract the seconds, it's no problem. You have 0 seconds. You subtract the minutes, you should really write it down as 0, 1. But now you can't subtract 24 from 22, or you can't subtract 4 from 2. I mean, okay, so what you need to do is borrow. Make this 2 days, and then take the 22 hours that you do have, and then add 24 hours to it, which is 1 day. So now this number is 46. 6 minus 4, 4 minus 2, 2 minus 1. You have 1 day, 24 hours, 1 minute, 0 seconds. Okay, so here we didn't even, when we borrowed from the days, we didn't even add just something to the tens. We add something to the 10 hours and the 1 hours. We added 24 hours. You need to be careful with this. Just borrow correctly. Let us just do one more like this, but let it be adding. Suppose you have 22 hours, 44 minutes, and 50 seconds. And you want to add 5 hours, 20 minutes, and 30 seconds. And I'm going to change one number, please. About we add 58 minutes. Now you can do straight arithmetic initially. You can say you have 80 seconds and you have 100 minutes and you have 27 hours. Okay. And that's correct, but we're not done yet. This is more than 60 seconds. 80 seconds is 60 seconds plus 20 seconds. That is, it's 1 minute, 20 seconds. So you have the 20 seconds, but you need to carry over the minutes. So now you have 101 minutes. Well, that's 60 minutes plus 41 minutes. That is, it's 1 hour and 41 minutes. So this becomes 41 minutes, but then you add to the hour. So now you have 28 hours. But 28 hours is 24 hours plus 4 hours. I say 24 because now I can call that a day. It's 1 day, 4 hours. So it's 4 hours and 1 day. Since I have no days, I really have 0 days. So when I add the 1 to it, this is 1 day, 4 hours, 41 minutes, and 20 seconds. That is what you get when you add these two. Let me just try it one more time. I think this is harder, but it's more conventional. We're going to use the carryover system. That's what we always do. Well, this is 80 seconds. That means I carry over 1 minute, that's 60, and we have 20 seconds left over. This adds up to 103 minutes. Well, that's 1 hour and 43 minutes left over. And this adds up to 28 hours, which is 1 day, 4 hours. So we have 1 day. Now, of course, we didn't get the same answer. We got 20 seconds and 4 hours and 1 day, but somehow this wasn't right. So let me see why. Okay, so when I added those up, I said it's 100. It's really 102. And then we had a carryover, so this should have been 103 minutes, which is 60 minutes plus 41 minutes. So I should have a 43 here. So now they match. Maybe the way I just did it is better because I didn't make an error. But that would be the conventional way where we carry over. Or you could just add up the units, 80 seconds, 102 minutes, 27 hours. That gave us this, and then carry over. Either way, we get the same answer. This completes the section on adding and subtracting mixed numbers, and I guess times.